We're going to do a gravitation problem. Gravitation. So we have, this is a gravitation problem. We have here the axis. This is our system right here. And we have at the center, the Earth right there. The Earth is at the center, Earth. And we have the sun over here. So this would be your sun. And you have the distance. The distance between these guys is r. The distance between the Earth and the sun is 1.5 times 10 to the 11 meters. That's the distance between the sun and the Earth. We have the mass of the Earth. Well, let's put here the mass of your sun. The mass of the sun is 2 times 10 to the 30 kilograms. That's the mass of the sun, and the mass of the Earth is going to be, 6 times 10 to the 24 kilograms. So you got all your data. And what you want to find out is what is the force of attraction. You got a force here. Let's call it a gravitational force. Now, this force exists because there's a pull, and the pull is, if you want to find the magnitude of the pull, that's the gravitational force that the Earth exerts on the sun. Gravitational force that the Earth exerts on the sun. It's a distance force because look at all the distance between the Earth and the sun. But you need the magnitude. You need the magnitude of that force. To find the magnitude of that force, we're going to use the formula G, which is the constant of gravity, mass 1, which is the mass of the Earth, mass 2, which is the mass of the sun, divided by r to the square, which is the distance between these two guys, or these two particles. You can think of them as particles. So let's find what is the magnitude of that force. Okay. So the force of gravity is going to be 6.67 times 10 to the minus 11. That's going to be Newton meters to the square over kilogram to the square. This is the constant of gravitation. And you're going to multiply the constant of gravitation times the mass of the Earth, 6 times 10 to the 24 kilograms, times the mass of the sun, which is 2 times 10 to the 30 kilograms. We're going to divide all this by r, which is 1.5 times 10 to the 11 meters. And then you got to square this because that's what the formula tells you right here. You got to square it. So the force of gravity is going to be, if you do this multiplication, at the top, you're going to get 80.04. Let's go with the units. You got Newton. Okay, well, that's 10 to the minus 11 times 10 to the 24 times 10 to the 30. Okay. This is a 30 over here. And the units would be, we have the newtons there. We got meters square at the top. Okay, we got meters square. Then we have kilogram times kilogram is going to give you kilogram to the square, because kilogram multiplied by kilogram right here, kilogram and kilogram. If you multiply kilogram, kilogram is going to give you kilogram to the square. At the bottom, you got kilogram to the square. Now let's go to the bottom part. That's 1.5 times 10 to 11 meters, and you got to square this. So that's going to throw you a 2.25 times 10 to the 11 times 2 is going to give you a 22. And this is going to be meters to the square because you got to square the units also. You got to square the units. So what do we got? The meters to the square cancels with the meters to the square, kilograms to the square cancels with kilograms to the square, and your force of gravity is going to be 80.04 divided by 2.25 is going to throw you 35.57 times 10 to the, well, 24 plus 30 is going to give you that's going to give you 54 minus 11. So this is going to be 54 right here, 24 plus 30. And times 10 to the minus 11 times 10 to the minus 22, because this guy goes upstairs. So your force of gravity is going to end up to be 35.57 times 10 to the 22 times to the 22, that's 54. Okay, so that's going to be 54 minus 33. So that's going to be 1 right here. And that's going to be 2. So it's going to be 21 right there, 21. And these are newtons. And that's the way it's supposed to be, because the force is always measured in newtons. But another way to write this down is 3.5 times 10 to the 22 newtons. This would be the force of attraction. This would be the force of attraction that the Earth exerts on the sun. It's just the force that the Earth exerts on the sun. And the magnitude of this force is 3.5 times 10 to the 22 newtons. And there you go. You have a problem for gravitation. Thank you. We'll do more of these. See you next time.